I'm going to do this slightly differently to the way most of you have done it, I think. So the people who have seen your answer is right, but I'd like you to put this just on the side, maybe parallel to the working you've got, just so you can see you can do it a different way and you end up with exactly the same result, but you can make a decision about which way you think is better. Okay? So the first thing we should do before we get any equations written down is to find where's the origin. Where are we actually starting? Okay? So I'm actually going to put, hands up if you put the origin at the top of the building. Hands up? Yeah, okay. Which is fairly intuitive because that's what we did last time. I'm going to show you that you can just as equally put the origin at the street level. Okay? One of the things that will be nice about that is that my distances will be positive, but as you'll see in a second, it won't matter all that much, but you can pick different places. Okay? So let's say, let the street level, or let the origin, sorry, be at street level. X is our displacement function. Right, now, we were saying before that we're dealing with the same kind of number for gravity. We're going with 9.8. Again, sometimes you get 10, but it doesn't really matter. If we say acceleration then is equal to minus 9.8. This is something that we always know. It's the same throughout the system. Okay, if we were to graph this, then the acceleration would just be that constant. Okay, how am I going to get from here to velocity? I'm going to integrate, right? Okay. Now, just like before, you get the same kind of function. So you're going to be writing this a lot of times, okay? Because many objects obey these kinds of rules, right? But when we're working out the constant here, now we've got something different to starting at the origin and being at rest at the beginning, right? So I would say, but when time equals 0, what's the velocity? Well, it was given to us as this speed in the upward direction, right? Okay, happy with that? So now when I'm working out my constant, okay, 40 equals minus 9.8 times 0 plus 1. Okay, so now I have a value for that constant, which is not 0. Okay. Therefore, there's velocity. Okay. Now I want to know, that'll tell me later on, it'll tell me how long it takes and what speed it's going, right? Okay. To go to displacement, let's integrate again. Okay, again, because I didn't pick the origin being up there, okay, I've got a non-zero value for my initial condition, okay? So I'd say, but x of 0, the value of x when time is 0, is equal to 100. Okay. So you can see, again, these are going to cancel out over here because they all depend on time. So I'm going to get x being equal to You happy with that so far? Yeah? Okay. Now, by the way, this is the reason why sometimes as mathematicians we can conveniently forget, unlike physicists, that, 9.8, I can just sort of mix and match the numbers because this is an imaginary system. So sometimes you'll see 10, for the express purpose, the exam marker has just wanted to make this easier to factorize, okay? Unfortunately for you guys, there's no factorization there. So you went to quadratic formula, and you should have gotten 2 values for time when you're trying to solve for displacement being 0, okay? So I probably should have said something before. The ball hits the ground when x equals 0, when displacement is 0. So if you chose the origin to be up here, you would have had to have said x equals minus 100, right? And you would come out with exactly the same equation. Do you see how they're equivalent? So, what were our 2 values? Can someone give them to me? What were the 2 times that we got? think it's like minus 2 point something or minus 1.9 something. Anyone got it? What did we get? Oh, you're special. Okay. Did someone? Okay. Who? I'll ask you in a second what you did. Someone solved this. What did you get? Should have both values. You've got to write down both. So, did no one solve it this way?
10.169.
Okay. Can I have the other one? It's quadratic. Two solutions.
2.006.
2 point
006.
minus 2 point.
Yeah, minus 2.006.
Thank you. 006 becomes 1, right?
Yeah.
Okay, now, this is important. You do actually have to get, from this equation, you have to get both answers even though one is invalid. Okay, it's a shortcut to just say, I just want the positive value. Sometimes you don't. If I didn't say that t equals 0 is t is greater than 0 is the domain, sometimes they'll say, for instance, t equals 0 represents 12 noon. Okay? In which case, negative values for t are meaningful. Okay? Minus 2.01, I guess, would be like 9.59 or something like that. Okay? So you can't just take a shortcut and not write it down. You must have it there. I know in this case we're going to discount it, but t is greater than 0. Okay? Greater than or equal to. Okay? But please, don't just not write it. Okay? You must include it. Alright, so therefore I just have my one value, 10.17. Okay, so what does that tell me? What does that correspond to? It means that he throws it up, comes back around, and after 10.17 seconds, it hits the ground. Okay, now that was one of the questions. What was the other question? How fast is it going at that time, right? So how do I get that?
Solve the time into the velocity function.
Good. I'm going to take that 10.17 we just worked up, and I'm going to bring it back to here. Yeah? So velocity is equal to minus 9.8. Okay. What did you get? 2 decimal places?
Negative 59.67.
Yep, that sounds about right. 6, 7. Yep. Should have put that up here. Okay, so what does that tell you? Does this make sense? What does the minus indicate? It means it's going downward. Check. What does this 59.67 indicate? Well, he throws it up at 40. Okay? Do you remember when we were having a look at questions like I was throwing that mandarin up and down, right? When something's just being acted on by a constant acceleration, if he caught it again, he leans over the edge and catches the ball on its way down. Okay? Just like that, and it stops there. How fast would it be going? If he caught it exactly where he threw it from? Answer, exactly the same. He threw it up at 40, it'd come back down at 40. Okay? But because it ends up falling an extra 100 meters, that's why it has the opportunity to pick up a little more speed, okay? Based on whatever your acceleration is, okay? So it hits the ground after 10.17 seconds, traveling at done. Okay? Does anyone have any questions about the process we went through? Joe, how did you get your time?
I split it. So I did, you know when I throws it off?
Yep.
So I put that as one equation.
Yep.
And then I got the value for that time for that.
Okay,
And
yep.
then when the ball, I calculated from
You worked out the
top
downward
to
part.
down, and
Yeah,
then
okay,
I added
yeah.
it.
So, was that the same amount of work? Extra work? Less work?
It looks around the same.
Around the same?
But I
Okay.
think the size faster.
Okay, sure. I guess we want to try and keep the equations we have as simple as we can to represent the situation faithfully. Okay?